Hi, my name is Professor Mac, and today I'm studying a law which affects us every day, and that law is Newton's law of universal gravitation. Gravitational force is an amazing force of nature. You may think of it as a force of attraction. That is because every object attracts every other object, whether that is me, you, or any of the items around you. This attraction is due to you and the objects having mass, where mass is the amount of matter in you and in the objects. The larger the masses, the greater the force of attraction. Just think about that for a moment. There is a force of attraction, a gravitational force, between you and every other object around you, due to you having mass and the other object having mass. For most objects, you can't feel the force, as it is very small, but there is one object very close to you which is so massive that you definitely can feel the attractive gravitational force, and that object is Earth. Earth and you attract each other, and since Earth is so massive, this force of attraction is larger than that due to any other object around you. The gravitational force from Earth on an object is known as the weight of the object. If I step on these scales, you can see that my weight is registered as 700 newtons. This is the gravitational force between me and the Earth. It is the force of the Earth pulling me towards it. Scales that are calibrated for use on Earth display your mass rather than your weight, so the display will normally show your mass in kilograms rather than your weight in newtons. The mass of an object is a measure of the amount of matter in the object. It is not the same as the object's weight, which is the attractive force between it and the Earth. However, they are related, since if the mass of the object doubles, the weight of the object will double. In the case of these two apples here, there is a gravitational force acting on each of them from Earth, and this is their weight. The weight of the apples are different due to the difference in their mass. In the case of the large apple, it has a weight 10 times that of the small apple, due to it having 10 times the mass of the small apple. So what will happen if I drop these apples over the edge of the platform here? Which apple will hit the ground first? Remember that the large apple has a much higher force on it due to its weight. Do you think it will hit the ground first? Well, let's see. 3, 2, 1. Oh wow, did you expect that? They both hit the ground at the same time. So what happened? Well, the amazing fact is that all objects accelerate at the same rate due to the gravitational attraction of the Earth. Heavy objects and light objects all drop at the same rate. Why is that? Well, in the case of the apples, the large apple has a force on it which is 10 times larger than the force on the small apple. So you may think that it would accelerate to the ground faster than the small apple. However, the large apple also has a mass 10 times larger than the mass of the small apple, and it therefore resists the acceleration by a factor of 10 times. The result is that the acceleration of the large apple is not greater than the small apple. It is exactly the same as the small apple, and therefore both apples hit the ground at the same time. So we have seen that the gravitational force between Earth and an object gives the object weight. So what happens in space, where you may have seen images of astronauts floating in a state of apparent weightlessness? Does this mean there is no gravity in space? Well, the answer may surprise you. So let's go up into space to find out more. Well, all systems are ready for takeoff. So let's go and see if there's gravity in space. 3, 2, 1.